Dr. Harshit, could you just stop your screen share? Sujata will share her screen for the initial part.
Sure.
So good afternoon all. Welcome to the third session of the industry assisted lecture series on AI on IoT. We are very thankful to IBM Research Labs for doing this for us in the last two sessions, and today is the last today is the third session rather. We are in discussion with IBM for trying to see if we can accommodate any more sessions, but we'll get back to you on that. Today we have Mr. Harshit Kumar with us. I will do the introductory part a little later, but before that, just wanted to remind all of you of the little small rules that we have set for ourselves to ensure that we have a maximum reach for the session. So as soon as you log in, it will be better if you ask questions also. It will be better for me to identify you, rename your Zoom name, include your college short name. All of you will stay muted. I know we are doing this for a purpose because the room size is large. We don't want unnecessary distractions, and hence we are keeping you all muted. Based on our last experience, couple of sessions experience, we have also disabled the chat box. But that doesn't mean that the interaction is not possible. Whenever at any point in time during the session or during the Q&A segment, if you have a question, kindly raise your hand. I will give you access to, I'll give you permission to unmute yourself and you can ask questions. However, during the session and you wish not to disturb the audience, you can always write a question back to askpalspmo@gmail.com. The email ID is flashed on the screen. Make sure to put your college name and your name also so that I can identify you. I will as soon as we start the session, I will be sharing the attendance link. I will also share the Slido link. Make sure that you give your attendance, mark your attendance. Marking attendance is mandatory. And the Slido registration is also important. At any time during the session, we will decide when to conduct the quiz. We will be displaying the quiz questions for you based on the session today. Feedback link, recording, and all that will be shared as usual post the session. So with that, I now invite Kamakshi Pandit from Brilliant Engineering College. Mr. Harshit, Kamakshi is a student representative. She's been attending both our sessions last in the series. So she has volunteered to do a small summary of both the sessions that has been taken, and I hand it over to her now to do to proceed. Kamakshi, go ahead.
Good afternoon all. Welcome to the third session of the Industry Assisted Lecture Series on AI for IoT by IBM Research Lab. I am Kamakshi Pandit from Brilliant Institute of Engineering and Technology of EC Department. As we know, this is our third session on AI for IoT. I want to give a quick recap on our earlier sessions, so let us begin with it. The first session was conducted by Mr. Arindan Jati from IBM, where he explained about the basic concepts of AI for IoTs, where AI stands for Artificial Intelligence and IoT stands for Internet of Things. In this, he explained about the Industrial Revolution 4.0 and what does it mean, and it is very important in our daily life. The applications are artificial intelligence and machine learning. We discussed about how IoT data looks like and what are the different AI and ML. Machine learning can be done on IoT data. They include multiple tasks. Sir has been also focused on the topics like forecasting, classifications, anomaly detection, time series regression, this type of tasks which are mostly done on IoT sensors data. Then he also focused on cutting edge technologies that are done on this space to work on this IoT data. This session 2 was conducted by Ms. Pooja Agarwal and Mr. Pranjal Gupta from IBM. In second session, we discussed about AIOps and how does it manage the IT operation feed. In first part, they covered like why do we really need AIOps? Current method of resolving incidents are slow and reactive. The key features of AI Ops are breaking down data skills, providing real-time insights into IT systems, augmenting incident management with AI, and many more. In the second part is like introduction and the different stages of AI Ops, followed by the third part, which delves into the basic technical concepts in AI Ops. The topics that has been covered in this session was stage of AI Ops, maturity levels within AI Ops, how AI Ops helps clients, key metrics for improvement, IBM Cloud Pack for Watson AI Ops, AI model management training setups. These were the topics which was covered in the earlier sessions. Now, our third lecture series, AI for IoT, is going to begin. This is on FM for AI Ops. For IT operation is a powerful platform that cites reliability engineering used to automate and streamline operational workflows with minimal human intervention, large language models such as bidirectional encoder representations for transformers and GPT-3 are trained using self-supervision on a vast amount of unlabeled data. This model provides generalized representation that can be effectively used for various downstream tasks with limited labeled data. Motivated by the success of LLM in diverse domains like science and biology, this talk will present the challenges and the solutions to build an LM for log data and applying it for downstreaming AI ops task. The speaker for the day is Mr. Harshit Kumar sir. Please, please join me in giving a warm welcome to the exceptional Mr. Harshit Kumar sir. Harshit Kumar sir is a senior technical staff member at IBM Indian Research Laboratory. His research interests are in AI ops, conversation AI, and information retrieval. He is currently leading the efforts in building AI solutions for IT operations and service by leveraging large language models. He is focused on adapting and applying various deep learning and natural language processing techniques to build an AIOps platform that can empower supports engineers to triage ongoing issues and to build fault resilient systems. Prior to joining IBM Research, respected Harshit Kumar sir completed his PhD in Computer Science and Engineering from the Seoul National University. Now I welcome Mr. Harshit Kumar sir to join us and continue the session. Thank you.
Thank you, Kamakshi. Sir, over to you for the taking the session forward.
Thank you.
And welcome on behalf of all of us once again, sir.
Yes, thank you. I will share my screen now.
Yes, sir.
Let me know if you can see my screen.
Yes, we are able to see your screen.
So thank you for the warm welcome. I appreciate that with all sincerity. And thanks to Kamakshi for summarizing the previous two sessions. The first one was on AI for IoT. The second one was on introduction to AI ops. So the previous session was taken by Pranjal Gupta and Pooja Agarwal, and they gave you an introduction of AIOps. And as you all know by now, AIOps is the application of artificial intelligence for IT operations. Today, what I am going to do is I'm going to talk about the foundation model for AIOps that we have been developing at IBM Research. I'm not very sure how many of you are comfortable or are aware of the term foundation model. It is a relatively new term, maybe 2-3 years old. Can I have some way of knowing through chat or poll, right? Is it possible to conduct a poll, ma'am, so that we know? I see. I just want to get an estimate of out of all the people who are attending, how many of them have heard about or are comfortable or know about foundation model? That would help me in basically help me in structuring the language I use when I communicate about foundation model for AI ops, right? It will also help me in articulating myself. It will also help me in how deep I need to go. So because if I go too deep to the very basics, it may be the case that many of the people will find it boring. They already know about it, right? So just to get some estimate of, yes, that, thank you so much. How many people know about foundation model? Good. This is a good number. Okay. Yeah, please everybody participate. That is very helpful for me. I think we have how many what is the attendance?
As of now, 406 participants are there.
Okay. So 130 have participated.
130, it's increasing.
Yes.
So requesting all the participants to make sure that you give response to this poll. So all this will only give us a confirmation that you are part of the session.
Yes.
And you have just not logged in. I don't know, somebody has ended the poll already. Some co-host, I don't know. No, it is not yet. Oh, it's starting again.
No, I think it is recalculating. So yeah. So there are 420 something participants. 170 have expressed, have answered it. 180 now. We are still waiting for another 200 so to respond. I hope everybody is hearing that. That is a feedback. In this virtual environment, how many people are actually there?
Yeah, true. That is
Right?
exactly what we are saying.
I
There is
am
no
not,
other way we know that, they are there.
I am not going to move unless all 440 respond.
%50 have done. Rather,
Yes.
50%, please wake up. If you have just logged in, ensure that you are there now, present and answer this question.
It doesn't take a lot of time. You just have to say yes or no. I don't know. Why is it taking 1.5 minutes to answer this simple question? You know it or you don't know it, right? I mean, it's 250, still for 54%. Oh, there are more people joining.
Yeah, there will be.
Oh, okay. People are joining. More people are joining. 450, 460, 61. Yes, good. So just for those who have recently joined, we are conducting a poll to understand how many of you are aware of the term foundation model. Why do I want to know? This is no exam for you. This is just to help me, to help you, right? Because if you tell me I don't know anything about foundation model, I will be articulating myself like a 5-year-old. But if you tell me, well, we know foundation model, I would be articulating like with the expectation that you know about foundation model, right? This will help me articulate myself better, and it would make it interesting for you to listen to me. Otherwise, I may say something assuming that you already know about it, which you don't. Then in that case, you won't understand, you won't like it, right? So this whole exercise is to help each other so that we both enjoy this 1.5 hour session, right, that we are going to have. And I do want people to ask questions. The more you ask questions, the more I feel that we are engaging. And, as a speaker, that gives me confidence that I'm not talking to a wall, especially in these virtual environments. If I am the one who is speaking for 1 hour, I lose interest. Let me tell you very honestly. If I don't get any questions, it looks like I'm talking to a wall, right? Nobody wants to talk to a wall, right? It's very discouraging and very sometimes can be boring also. So please do ask questions, and I will ensure that every question you ask, I will answer it to your satisfaction. I won't move ahead unless you are satisfied. Good. We have got 500 people and 300 have already responded. Yes. 63% is the participation. And we have already spent 5 minutes for this exercise, which is amazing. That why would we need 5 minutes? I mean, 4.5 minutes. It will be 5 minutes soon. Why would we need 5 minutes for this exercise? It is just clicking a button. Maybe some of the people can decide if they know enough or not, right? In the interest of time, may I ask to stop the poll, because this is a good sample. If out of 500 I have 65% sample, so this is plain statistics, right? When we want to good learning for you also, right? In real life, it is not possible to collect the in any survey. It is not possible to collect the data from every participant, right? Not everybody is available. So what we do is we take a small sample of the whole population. In our case, the whole population is 500, 600, whatever, right? Out of which we have gotten response from 350 of them, which is like 67, 70% of them. So we know, right, from this, 46% of the people, they know about foundation model. 54% does not know about foundation model. So that's a 50-50, so there is no conclusive evidence here. You see, this is an interesting exercise. There is no conclusive evidence. I can't draw any conclusion from this exercise, because half of the people, they know about foundation model. The other half does not know about foundation model. So I would like to go with the other half who does not know about foundation model. So I would be going slow, talking about foundation model, because my real audience is those who do not know about foundation model. I'm not saying those who know, they are not my audience. They will definitely gain from what I will tell you. I can promise you. By the end of this session, you will know something more that you didn't know. I can promise you that, right? This poll is still going on, 70%. That is good.
Can I close the poll?
Yes, you can. I think we can close the poll, right? We have 70%, right? We can, and it's 50-50. Yeah.
Yeah. So this is what it is.
Okay, good. So with that, yes, some of you were typing on the chat. That doesn't help. We can't, count how many are saying no and how many are saying yes. So there was a poll for that, right? Don't type on the chat window. Doesn't help us. But do ask questions. Please do ask. If you want to thank me, ask questions. That's the only way you can thank me, right? Do ask questions. That is encouraging for me, right? So with this, I am going to, I plan to divide my talk into 3 parts. The first one is about AIOps, which most of you already know, but I will put it from a different perspective. I have been doing AIOps for the last, since 2019. It's been 4 years now. Yes, almost 4 years. So I I was responsible for setting up this team, and then this team has grown from 3-4 people we started with. Now there are 10 people, and two of those people presented in the previous session the previous week, right? they talked about what is AIOps. So I will spend some time talking about AIOps, so that I'm that is like laying a platform for me to walk on to explain you the further things, which is large language models. Foundation models are also known as large language models, right? So I purposefully, here I'm saying large language model and here I'm saying foundation model. They are one and the same thing, more or less, right? And I'm doing that purposefully so that you know that they are one and the same thing. So large language models, also called as LLM, right? This L, I am going to use my, hold on, I don't see something which is very strange. I'm so sorry for this. Some mix-up is happening. Is it because of Zoom that I don't see? Or is it something else? This is a Zoom window. No. Okay.
You're having some difficulty?
I am looking for, in PowerPoint, there is, I can choose a pen marker so I can write on the screen. It helps me communicate better with participants, but I cannot find that here. Is it because of the Zoom thing, or is it because of something else? I'm just wondering. I can use this annotate. Um,
Yeah,
got it.
annotate is a thing. There is a
Yeah, I need that annotator so I can write something here. Yes, I can do that. Okay, good. So let's go to the previous screen. Now I cannot go to the previous screen. This is who can see what you're doing. Okay, if I go here now, if I go here, yes, okay, I understand what is happening. Got it. So we were talking about yeah. So I'm going to start with AIOps, then I will talk about large language models, which are another word for foundation model. And once you understand what a foundation model, I will show you, or I will talk about some of the applications of foundation model for AIOps. So we have actually built a foundation model and we applied it for AIOps, right? So let's start with a brief introduction to AIOps, right? Okay. So I am motivating why do we need AIOps at the first place. I think Kamakshi, who did a summary, did a good job of it. She mentioned one statement, and so why do I need AI for operations? Way back a few years ago, if any application that is being used by multiple people, it it stops working or there's an issue with it, many people would come in a room like this and they would sit together to find out what the problem is. There would be people from networking team, there would be people from software development team, people from storage, because they don't know what the problem is, right? They need everybody in the room, whosoever is required to come and let's solve this problem. It is super important because our website is down. People are not able to use our website. This is so they were coming to actually a physical room solving the problem. it's not very efficient, as you can see, right? You don't need all the whole team of people spending the whole day or maybe more than a day to solve that problem, right? And now we are actually having more and more digitization. As you know, UPI is, we are having record transactions. If a system like this goes down for even a minute, you can imagine what would be the financial implications of it, right? Many people won't be able to do transactions, the inconvenience, number one. Some businesses will actually lose, business. They will lose their revenue if this thing stops working even for a minute. So you can understand there are certain systems now that cannot afford to go down even for a minute. If Insta goes down, Facebook goes down, WhatsApp goes down for 5-10 minutes, there would be, on Twitter, people talking about it, right? It will make a lot of noise. These are the systems that we use on daily basis. They cannot, because it affects our day-to-day life. So how do we ensure that these systems, they are always functioning, and if they go down, they come back as soon as possible? And that is what this AI for operations, AIOps, is for. So there is, as I said, digitization is increasing with each year, right? And this digital shift, which is happening, in the last 5-10 years, basically means that the business operations are becoming IT operations, and IT operations are becoming business operations, right? And this is the HBR, Harvard Business Review. Okay, it's a study which was done, which said that 77% of the businesses, if there is a business and IT disconnect, it could result in a significant cost, right? And 69% improvement in IT OKRs have no effect on business OKR, right? So more dependency on ITs. And it is very important, 89% feel that it is very important to align the business and the IT so that they can make better decisions. Right? So basically, the bottom line is that there is a digital shift which is happening, and IT and business should come together. I hope you all agree with that. And our applications are also growing complex. Way back, there would be a simple application consisting of few microservices, one database, and they are interacting with each other. But now, in today's world, the applications consist of thousands and millions of microservices, and they are interacting in a very complex fashion, right? Can I move this thing? Okay, this one. Okay. And customer experience is the most important thing, right? So the companies, they act upon the customer data, and based on that, they make decisions. So not only these applications are becoming complex, they are very dependent upon how customers interact with them, right? And they use the data that customers provide them, how they are using it, what time of the day are they using it. So customer experience is one important part. And because of the business and IT disconnect, the cost can increase significantly, right? It has been observed that the business team who are building that application, the business logic, and the IT teams who are managing, they have some disconnect with them, and that could result in a significant cost. So AIOps bridges those gaps between the business team and between the IT team, right? Okay. I have already talked about this thing, that 85% of the IT leaders say that they do experience frequent unplanned downtime, which means that these applications can go down, right? There is an expectation that they can have an unplanned downtime, and due to which businesses can lose revenue, right? And that's a significant thing for them. They don't want to lose revenue. So but also they not only lose revenue, they also lose the customer, right? Some customers, they may not want to come back if the service or the application that they are using is very unstable. Okay, now a 1 second increase in application latency. What is application latency? Application latency is you submit a request when you're browsing a website or you're doing something, and how much time does it take for the results to come back? That is the latency, right? So 1 second increase in application latency, right? Just 1 second increase would lead to a 7% down in customer conversion, right? You can lose 7% of the customers if the application latency increases by 1%, right? And 47% cloud spend is required to target that application latency, right? So either you increase your cloud or you improve the AIOps, which is automation. You automate, the how do you respond to the issues that are going on with the application? How do you identify what are the issues that are going with the application? This is like basically either repair, right? So there's a thing. Let's draw an analogy here. I have a car which can break on the road. Either I can repair it, right, and ensure that it does not break, or I can have um, a preventive mechanism that even if it breaks, that preventive mechanism would take care of it uh, while I am on the road. AIOps ensure that while you're on the road, if something breaks down, there will be some fallback mechanism. Things will come back to normal as soon as possible so that you reach your destination. That is the whole aim of AIOps. Customer not getting affected even if there's an issue, right? And for that, we need to put some automation into it. Now, although we are saying we need to put some automation, it do need human involvement. Human and the machine, they work together. It is still not 100% automated. So there is a lot of scope of improvement as we move into the future. Currently, it is 50-50. AIOps does some automation on its own, but plus some effort is required from the human. I'm not watching my chat window, so if there are any questions, please. I'm sure Sujata is keeping an eye on the chat.
I'll moderate, sir. I'm looking at the mailbox as well as the chat window. I will moderate it for you.
Thank you.
Yeah.
Please do ask questions. Stop me. You have the control, right? If you
they can't ask questions. You can write to us in the email, or you can post your questions in the chat box. It will directly come to the host only. It won't go to everyone. I will moderate it and I'll ask those questions.
So let's try to understand what is Watson AI in very simple terms. Okay, your application is running. Think of, let's take an example here. Okay, I'm sure each one of you have booked a train ticket or booked a flight ticket, right? Let's take an example of train ticket. So when you book a train ticket, you provide your source from where you're boarding the train, destination where you're going. You may even want to book a round trip ticket, right? You may want to say on this particular date at this particular time, you want to put some constraints. So it sounds simple, but you all are coming from the IT background, so you know how much business logic we need to put in the background to enable such applications, right? Now, when this application is running, which means that somebody is booking a train ticket, the logs will be generated, right? And that logs, not only logs are generated, the metrics are also generated. I'm sure Pranjal and Pooja talked about that in the previous one. So logs are generated, metrics are generated. There is a topology that the application has, which means that this microservice interacting with this microservice and so on, right? And there are a bunch of other things that gets generated, configuration files and all that. All that data is being watched by the AIOps system. It is watching that data, messaging that data, collecting that data, and then correlating that data. Correlate basically means data coming from logs, data coming from metrics. You need to make sense of that data. You need to bring them together, right? So that this log for this metric, right? So you need to do that correlation of the log data and the metric data. And once you do the correlation, you get to know of some insights that you show on the AIOps dashboard, right? In the operations dashboard. And once it is on the dashboard, one can execute a run book. Now, what is a run book? Run book is as simple as a manual that is saying, if this happens, do this. If this thing happens, then do this, right? Set of rules one can follow and resolve the problem, right? So AIOps dashboard tells you what is the problem. Run book helps you solve that problem, but part of it can be automated. Once you know the problem, you know the run book, you can automate by connecting them. However, not all problems can be addressed by the run book. Life is not that simple, right? Had it been, everything would have been good. But yeah, most of the cases or frequent cases can be taken care of by the run book, but there are certain borderline cases where human involvement is required, right? So that is what at a high level, collect, correlate, show the dashboard, and then the run book would tell you what to do to solve this problem, right? This is at a very high level. We'll go deeper. Now this, I don't know if Pranjal talked about this, but I use this diagram to explain, about the Madan Kumar has raised hand. Madan Kumar, do you have a question? No. Okay. So I use this diagram to explain in more detail what is AIOps. So please make sure that you understand this, right? So an application, as you can see here, there are three circles, hollow circles, and this one is a database, right? So these three microservices are interacting with each other, and when they are doing so, they are some metric data is generated, some traces are generated when the interaction happens. Interaction means a user, a human being, is using this application, right? This microservicing calling this microservice, reading from the DB, and so on. Now, metrics and traces are largely structured data. There are aggregators like Instana for metrics data. They aggregate the metric data coming from the application, right? Also, logs are generated, but logs are unstructured. Again, it's an unstructured data that also needs to be aggregated. Why do I need aggregation? Because my logs are coming from multiple services. This service is emitting log, this service is emitting log, and this service is also emitting logs. My database are also emitting logs. So all those logs, they need to be sorted by time and aggregated, right? So I can actually analyze the data. I can look at the whole. When I say I mean the AIOps system. AIOps system can look at the logs and draw some inference, what problem is going on, right? If any. So these are log aggregators. This is metric aggregator. These are observability platforms. Instana is an observability platform. It allows you to observe the metric and traces data. ELK log DNA is another observability platform for logs data. Okay, so you get alerts, metrics, and traces. They go to the AIOps system, and similarly logs also come. Now here the magic happens. We identify in AIOps, are there any log anomalies? You know what is anomaly? Anomaly is something which is, if I'm driving a car or any vehicle, if I start hearing some sound, I would say, I have never heard this kind of sound in my car. Something anomalous is happening, right? So logs data, if I observe, if my AIOps system observes something that it never saw before, or something strange, some different pattern of log data, that are log anomalies. Similarly, metric anomalies. In the metric data, what is an example of metric? Body temperature, human body temperature, right? My body temperature, if let's say I have a sensor attached to my body and it is continuously emitting the temperature, right? If the temperature is between 98 and 99, that is normal. But if the body temperature is above 100, that is an anomaly, right? So what you see, this is metric anomaly, right? So I have metric anomalies being detected by my AIOps. I also have log anomaly being detected by my AIOps, right? For the same body, right? For the same vehicle or for the same application. Now I need to correlate these metric anomalies and log anomalies. By the way, metric anomalies and log anomalies are also called as event. One single term for both of them. Event. Metric events, log events, or metric anomalies or log anomalies. If you will read somewhere, people may just use the word events, right? So these are the metric anomalies. These are the log anomalies. We correlate them, right? To the which service are they coming from? If they are coming from the same service, they are related to each other, right? Metric event, log event coming from the same microservice, they are related to each other. So we group using this logic. If they're coming from the same microservice, we group them together, and that is called as event grouping, right? So identify log anomalies, identify metric anomalies, and then group them together as much as possible. Once we group them, we call it as a story or an incident, right? A story or an incident consists of metric anomalies, log anomalies, and we are also able to identify there what the fault is, where the fault is. It is obvious here. This service has the fault, this circle, this is some service. Maybe this service is for login, right? Or maybe this service is for making the payment, right? So this service has the fault where my mouse is. So we know fault localization. And when this service gets impacted, what are the nearby services that can get impacted? That's like blast radius. So for example, an analogy is, if a building catches fire, what are the buildings in the vicinity that can get affected? That is the blast radius, right? Similarly, in an application, if a service is getting impacted, what are the nearby services that can get impacted? Obviously, those will get impacted that interact with this service, right? Somebody that does not interact with this service will not get impacted. So blast radius computation is done. So this story contains log anomalies, metric anomalies, the nearby services that get impacted, which is blast radius, where the fault is, fault localization. So four things, in four major things are there in this story, and that is what we call as an incident also. And once we know what is the problem, we show that on a screen. It could be a phone screen, it could be a computer system, right? It could be your WhatsApp. Anywhere we can just send that story to that thing, so that support engineer can look at it, and Runbook will help solve the problem, right? This is the whole pipeline. So summary, observe. This is the observation, right? First, collect data collection, log aggregator or event aggregator. Then second step is detect anomalies, log anomaly, metric anomaly. Then correlate those events, log anomaly events and metric anomaly events. Then fault localization, blast radius, right? Computation. And that is what we call as an incident story. Send it to the user, right? Through WhatsApp or through chat, any collaboration platform. And then run the run book to solve the problem. This is a typical AIOps pipeline, right? Lot of work is being done here, even here, and all of these places, right? We want to automate, right? All of these places. So this is what AIOps is about, right? Any questions? If not, then we can go to the next part, to the foundation model. What is AI? What is artificial intelligence? You all already know about machine learning from Arindam Jati in the first session. He talked about machine learning. I am going to talk about artificial intelligence, which is built upon the machine learning, right? But I will start from some basics. But before I go there, I want to make sure that all of us understand what is an AIOps type. I have taken 20-25 minutes to do justice with the AIOps. If there are no questions, I would pause for a minute, wait for questions, and then we can go to the artificial intelligence.
If there are any questions, you can raise your hand. I'll unmute you. That will be faster. You can also write to us in the chat box, but that message can be posted only to the host and nobody else. You can also send an email to, I've been posting askpalspmo@gmail.com. There is a question, role of anomaly detection with clear example.
Good. I can draw an analogy for you. I tried to, but I think I failed. I gave you an example of temperature, human body temperature, right? See, it's a very good analogy if you will just be with me and try to understand. Okay. Human body, I can put some sensors who will monitor the heart rate, who will monitor the temperature. Heart rate is one metric. Temperature is another metric. Blood pressure is another metric. There could be maybe pulse rate, another metric, right? So 4 metrics are being observed, right? Now, anomaly detection is what it is doing. It is detecting, is the value being observed by the sensor, is it deviating from the standard? As simple as that. That is anomaly. For example, we all know human body temperature, right? 98.6, all good, right? Above 100, there's a problem, right? Sometimes you don't even know that your body temperature may go over 100, right? If I could have a sensor, smart watches are doing that to a certain extent. They are detecting anomalies. They would tell you your body temperature if it goes above 100. If your heartbeat goes above a certain number, if your blood pressure is beyond 120 and 80, right? 120 and 80. If it is above 120, then there is a cause of concern. That is cause of concern is an anomaly. That is what, right? As simple as that. In the AIOps world, an application is continuously emitting some metrics. For example, memory utilization, CPU utilization. If CPU utilization or memory utilization, or if the response time, right? There could be several such metrics. If they go beyond some, acceptable numbers, those are anomalies, right? I hope that answers what is anomaly detection. I gave you 2 examples, a real life example, human body, and in an application. Yeah, there are a couple of hands being raised. I'm hoping there are questions, so we can move to the next question.
Those who raised have dropped it down, so I don't think they had a valid question.
Okay.
Akib, if your question is answered, that's fine. Otherwise, if you have a follow-on question, write back to us.
Okay.
You
So
can
maybe
proceed.
yeah, I will move to the next one. So I want to talk about now foundation models, large language models, right? These were the 5 questions when we started working on foundation models. Do we need a foundation model for logs, metrics, and traces? What are the downstream tasks for the foundation model that we want to build for AIOps, right? And there are existing foundation models such as ChatGPT, BERT, Roberta, right? Can we use them straight out of the box? Why do I need to build my own foundation model, right? And what are the complexities that are associated with IT ops data? So these were the questions. You will learn here, at least learn from me, what is the thought process that we went through when we build a foundation model, and what type of foundation model do we need. So to answer these questions, I have a bunch of slides as we move ahead, and we will come back to this right at the end to answer these questions, right? Is my data, log data, metric data, do they have some complexities, right, that these existing foundation model cannot address, right? And if they cannot, then what type of foundation model do we need? So for that, you need to know what are the different types of foundation model, and I will talk about that in a while. So these are the questions to motivate the rest of the presentation. But before I jump to straight to foundation model, I think I need to do justice with what is a foundation model. More than that, I need to do justice with what is artificial intelligence that we all have been hearing. From a layman's perspective, what is AI, right? Is it some magic wand? No. Um, People have been working on AI for the last 30, 50 years. You would be surprised to know. When I was doing my undergrad, there used to be a course, Introduction to Artificial Intelligence, which is way different from what we are doing now in the AI world. We used to do some these search algorithms and all that stuff, right? But now when we talk about AI, it's a little different from that. So I am going to lay some foundation for AI today. Okay, we will first, I will talk about what are the downstream tasks in AI ops from my lens, from my perspective. There are many tasks in AI ops, right? But from my perspective, when we wanted to build a foundation model, we wanted to know what are those tasks for which we want to build a foundation model. So these were the tasks that came to my mind. Format detection. Given a log line, what format it is. I will show you some examples. Spend 5 minutes on all 5 of them, right? Golden signal classification, fault classification, entity recognition, and incident summarization. You know what is incident? Remember, that story is an incident, right? Summarizing that story, right? But what you don't know, what is golden signal classification, what is fault classification, what is entity. These things are important in building that anomaly detection, in building that log aggregator, right? Log aggregator will use entity detection. Anomaly detection and event correlation will use golden signal classification, fault classification. So these are very low level tasks, right? Let's go into that and you will know what these are. So what is the format detection, log format? The name speaks it. Given a log line to tell where is it coming from, right? Is it coming from Hadoop? Is it coming from WebSphere? Is it coming from Spark? Is it coming from SSH? Is it Windows log? Is it Linux log? Right? So I want to build a system that can take as input a log line and tell what type of log line is it, right? As simple as that. Simple, very simple task, actually, log format detection. The next one is golden signal classification. This is very important. Golden, even the word is golden here, right? I keep making fun of this golden signal classification as if some golden eggs right? But they are golden eggs actually. When the support engineers, when they look at logs, they have a mental model. They mentally classify each log line into availability problem, error problem, latency problem, saturation problem, traffic problem, or information. Let's take an example. What is availability? Availability means something is not available, right? It says here, state change unavailable. Something is not reachable. I am pinging an IP address. That IP address is not reachable, which means it is not available. Human analogy, I'm calling somebody, he's not picking the phone. What would I say? The person is not available, right? What is latency? Latency means something is taking time. I am sending something, but it is taking time. That is latency problem, right? Another example of availability here is that something not found. I'm searching for something, it is not found. That is availability. So it's a mental model that we are trying to model here as a task, golden signal classification, right? An error is obviously very easy to spot. You will see something is not working. Something is not, throwing an error. Exception. Those are all errors, right? Availability is a special kind of error. Latency is special kind of error. Saturation, special kind of error, right? What does saturation mean? Saturation means I have 10 GB of memory. I have already consumed 9 GB. That is saturating, right? I have 10 GB of memory. I need 11 GB, right? That is also saturation. So it's a mental model that the support engineers have when they look at the log data manually. We want to make it easy for them by providing this golden signal. And this is also helpful in doing anomaly detection, this information, right? What is the golden signal associated with the log line? Fault classification. Where the fault is the fault is with the memory, with the network, with the device? Is it authentication fault? Is it an IO fault? Is it an application fault, right? That is what basically fault category is. Entity recognition, very important. Given a log line, I need to tell that this part in the log line is a file path. This part in the log line is an entity, right? Or it could be exception. In natural language, David is going to Delhi, let's say. So David is a person, Delhi is a location. That is also entity detection. It is also known as NER, named entity recognition, right? It's a very, very common NLP task, natural language processing task, right? Very important for us because we have raw log lines. We want to know which part is file or dir, which part is IP address, which part is host name, which part is task ID, which part is version number, and so on. An incident summarization, you know what an incident is. Incident consists of 4 or 5 things: log anomalies, metric anomalies, for localization, blast radius output, what else? Grouping, right? Grouping of log anomaly, metric anomaly, and then providing a summary of it. That is what incident summarization is, right? So these are some of our downstream tasks for which we wanted to build a foundation model, right? Basically, we want to build a model that takes as input a log line and tell me which format is it, and can also tell me what is the golden signal associated with the log line, what is the fault associated with the log line, what are the entities in that log line, right? And if I have a story, what is the summary of that story? These are some of the tasks that we wanted to build a foundation model for, right? But my next question is, cannot I use existing foundation model, right? But to answer that question, we need to first understand what is a foundation model. So let's quickly go over there. What is a foundation model? So for that, I would like to talk about AI. What is artificial intelligence, right? So when you look at this number, please, what comes to your mind when you look at this picture here? Can you tell me on the chat, some of you, if you can write to the chat window? Ma'am, please enable. I want to see, because I will use that to draw some conclusion. Can you enable chat for the students?
Are you able to see? You can post it to everyone. Participants have enabled the chat.
Yes. Okay, good. Now
all of them are giving 3.
Yes. 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 Good. So this is actually 3, right? When you look at this one, this is also 3, right? My human mind, see, both pictures are different a little bit, right? You see the haziness in the first picture, in the second picture, right? But human mind is smart enough to be able to tell that the left side picture is a 3 and the right side picture is also 3, right? How do I teach a computer, given this image, to tell me that it is a 3? That is the task I have, right? But we also know that this is a 3 and this is a 7. They are not same. This is a 3 and this is a 6. So human mind can, it knows what is 3 and what is not 3. So human mind knows what is right, but it also knows what is wrong, right? So when I give a, yeah, just watch this. I will summarize. Okay. So what so you see, given a number, I make an array of 784. So let's go to the next slide. So given a number, I represent it. It's an image. For the computer, it's an image. 28 by 28. 28 rows, 28 columns, right? It's a matrix. I can convert this 28 by 28 matrix into 1 cross 784, right? Which is like this one. You see this one line, right? And everywhere I see here 0, 0, 0, 0, 0, 0, 0. But at some places where 9 appears, I see 0 0.9, 0 0.5, 1.0. This is to capture the image 9 as a matrix of numbers, right? And then I have my first layer of my AI neural network, right? This is the first layer, 1 cross 784. This is my input to my neural network. And then this input to my neural network is the first layer, 1 cross 784. There are 2 hidden layers, right? It's a kind of a transformation happening. You must have studied in the high school matrix transformations. From 784 to this one, from here to this one, and then to one of these, 0 to 9. The 9 one being white means this is number 9, right? This is how it tells. I have 2 hidden layers, 1 input layer and 1 output layer. This is what a neural network is, as simple as that, right? And why do I need hidden layers, right? Why do we need these hidden layers? These hidden layers are actually capturing the characteristics of the input, which was 9 in this case, right? And it is learning. You see, some of them are white, some of them are hollow, right? So these are also called as weights of a model. I'm building a neural network model that can learn, what a number 9 looks like through these hidden layers. That's what is the purpose of hidden layer. It can learn about 9, it can learn about 7, it can learn about 1, 3, 5. It will learn some bunch of weights here, right? Neural network is nothing but learning some bunch of weights, right? And based on when the input comes, it will be able to detect whether it is a 0, is it a 1, is it a 2, 3, 4, or 9. So, right? This is what a neural network is, right? So I have I have, as I said, summarize it. This is my input, 784 neurons, right? 2 hidden layers and 1 output layer. I can have more than 2 hidden layers also. I can have 3, I can have 4. It depends how complex my model is, how difficult the task is, the more number of layers I need, right? For a simple task, I may only need 1 hidden layer. For a difficult task, I need 2 layers, but there is no golden rule that tells how many layers you need, right? So, yeah. So what are these layers doing? As I said earlier, these layers are basically, these hidden layers are learning learning some weights for the digits in this case, right? Okay. Now, let's understand what is the classification is. Most of you already know about it, but I just thought maybe somebody who does not know. So one classification, so this is my neural network, the classification model, right? You just saw in this example a neural network, which is a classification model. It takes as input and tells, is it 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9, right? So 10 candidates, but it will predict only 1 out of 10, right? This is a classification system. But there are some classifications that are binary classification. Binary means there are only 2 options, right? Given incoming message, should it go to the spam folder? Should it go to the inbox folder? This is binary classification. You only have 2 choices to make. The model has to decide either send the email to spam folder or send the email to inbox folder. This is binary classification. What is multi-class classification? When there are more than 2 choices, send to spam folder, send to inbox folder, or send to offensive folder. There could be some emails that are offensive in nature, right? So send them to the offensive folder, right? There is something called as multi-label classification, and this is there's a small difference between multi-class and multi-label. In the multi-class, this mail will go to either one of them, either to spam folder, either to inbox, either to offensive. This is multi-class. In the multi-label, the incoming message may go to one folder or multiple folders. So which means that this message may go to inbox or offensive. Something can be offensive and also can go to my inbox also, right? So if my model says it is inbox and offensive, then that's a multi-label classification. More than one label you assign to a message, that is multi-label. Let's take another example to understand multi-class and multi-label, right? If you look at this picture, if I ask you one question, is it a dog or not a dog? It's a simple one. You will choose dog, right? It's a binary classification problem. This is an example of binary classification, depending upon what question I am asking. But now if I ask you, is it a dog? Is it a bus? Is it a car? Is it a truck? But you have to choose one only. You would still say this is a dog, right? But now if I ask you, you can choose more than one. By the way, this one is multi-class. You can choose only one out of these 4 classes, multi-class, right? But now, same picture, but now if I ask you, you can choose more than one, right? You would probably choose dog and car. This is now multi-label because you can choose more than one. So my model, right, would now make 2 predictions for this picture. That is a multi-label classification. Multi-class, only 1 prediction out of multiple classes. These are 4 classes. This is binary classification, only 2 classes, right? I hope this difference is clear. Binary classification, multi-class classification, and multi-label classification, right? With that, this is a summary of a neural network, right? When there are 3 neurons in the output layer, this is multi-class classification. When there are two neurons in the output layer, it will be binary classification, right? This is my input layer, hidden layer, and output layer. This is a typical neural network. Now, as I said, I can have many hidden layers depending upon the problem that I'm solving. I could have one hidden layer, 2, 3, 4, 5, lots of hidden layers, right? Which is called as deep learning. Many hidden layers is deep learning, deep, many layers. That is what deep learning is. So neural network to deep learning, right? So let's go to now foundation model. Deep neural network. As I said, you chain these neural networks, that becomes a deep neural network. I hope we are good with this. What is deep neural network? Right? Now, what is the foundation model? Okay. Foundation model is, this is one block. You see here? Now I need pen here. This is one block, one neural network. I have a chain, n such neural network. I chain them together, right? And that becomes a foundation model, large language model. But there is one more thing here. These models, they are trained on huge amount of data. I am using the word trained. Trained for what? They are trained on large amounts of data, right? Trained on what? Large data, huge. Chat GPT, BERT, BART, T5, they are trained on large data. But what is that training that that they were given? Very simple training. We call it as MLM, masked language modeling. M for masked, L for language, M for modeling. Okay. So what is MLM? What does it mean? I'll give you an example. I mask, okay, I'm going. Oh no, I mask going. Okay. I tell this model, for this input, tell me what is the word that will come here. Okay. If the model makes the right output, then the model has learned. If it makes a wrong output, then the model needs training. We keep training, teach him that it should be go, right? So this task is caused as masked language modeling, and it's a very easy task because you do not need anybody to prepare the data set for you, right? You can randomly mask some of the words in a sentence, give it to your model and ask your model, make a prediction, predict this word, right? So very, initial foundation models were trained on books. There are a lot of sentences in the books, mask some of the words and ask the model to predict those words and keep teaching them unless they make the right prediction, right? Let me erase this all. Okay. So this is about the encoder only foundation model, right? This particular MLM is an encoder only foundation model, right? There are examples, BERT, Roberta, XLNet. These are encoder only foundation model. But then there are decoder only foundation model. But remember I said you there are multiple types of foundation model. There are decoder only. Decoder are they generate sentences. Those are decoder only foundation model. And then there's a third type, encoder decoder based. They take as input, they do MLM, and they also generate. They do multiple things. Those are called as encoder-decoder based foundation model, right? Examples of encoder-only foundation model are BERT, Roberta, XNet. Decoder-only are GPT. GPT is a decoder-only foundation model, right? It does causal language modeling. Encoder-decoder does both of them, right? BART, T5, these are encoder-decoder based foundation models. With this, so now we know what is an AI neural network model. We also know what is a deep, like we saw in that, what is a deep neural network. And when I chain these deep neural networks using these transformers, I get a foundation model or a large language model, right? So, and there are three types of foundation model. Now that question comes, remember the downstream task I talked about? For these downstream tasks, do I need a foundation model? That depends upon the data that I have. I have log data. Have any of these models, BERT, Roberta, GPT, have they seen log data? Maybe they have seen, maybe they have not, right? So I can use straight out of the box one of these models for my downstream task. Turns out that they don't perform very well on the log data. So we do need to train our own foundation model. Why? Because log data has several challenges. Log data is semi-structured. It is difficult to interpret. It is also noisy. It is not grammatically correct, right? Look at this log line. It's difficult to listen. There is no grammar here. Look at this log line, servlet error com.ibm.ws. This is not natural language. These large language models like ChatGPT, BERT, they have been trained on Google Books, all the books that are available in the world, right? Wikibooks, Wikipedia. They have been trained on those. For which task? MLM task. They don't know, they cannot handle ungrammatical, short log lines, right? So these foundation models, which are BERT and all, ChatGPT, they don't work straight out of the box for us because of these challenges of log data, right? So what we did is we trained our own tokenizer, right? And then we trained a foundation model for ITOps, which is encoder based. Which one? Encoder based, the first one, this one, right? For MLM task. So we trained our model for the encoder based model. We call this model as BERT-ops. We have a paper on this, right? FM for ITOps encoder based model. We published this in IEEE Cloud this year. Pranjal, me, Pooja, we are all co-authors in that paper, right? So, and it's a simple, like I said, masked, right? Server not available, status 404. So we mask some of the words and we ask this model to predict that word, right? And then at the top, we have a classification layer that does log format detection, golden signal classification, fault category prediction, and so on, right? So we can, this is the fine tuning layer, the classification layer. And we talked about classification, right? This is the fine tuning layer. This is our, this is the foundation model that we are building, this part. So let me mark it here. This part is the foundation model. And for this foundation model, we build 3 more models: log format detection, golden signal classification, and fault category prediction. Right? So how did we use the foundation model for these 3 things? Right? Let's talk of that in the next slide. I have to erase this. So I have my input text, my log line, I have my foundation model, BERT-ops. Here I add a linear layer, which is the fine tuning. This linear layer is doing the classification, right? And it is telling whether it is an error, latency. This is my final classification layer, right? Is it error, latency, availability, information, traffic, or saturation? Very simple. Once you have the foundation model ready, you add a linear layer to do these things, right? You can do that for log format detection. You can do that for golden signal classification, right? Similarly, for the fault category classification, right? But now fault category is a multi-level classification. Remember, multi-level, more than one output, right? I can have given an input log line. I may want to say that this is of type device, is it of type application, more than one output, right? Golden signal classification is multi-class classification. Fault category is multi-level classification, right? So, and then log format detection is also multi-class classification, right? So, do we need a foundation model for logs, metrics, and traces? Yes, we do need, because log data is very complex. What are the downstream tasks? Remember those questions, right? I'm answering those now. Well, format detection, golden signal classification, fault prediction, entity recognition, summarization, right? These are my downstream tasks for which I need foundation, low level downstream tasks for which I want to build a foundation model. Can we use existing one like BERT, Robert? No, I cannot, because log data has its own complexities, which these models cannot address, right? And what type of foundation model do we need? We need an encoder-based foundation model, right? What is the encoder-based FM? Let's go back. This one. The first one is the encoder-based FM. What is the task when this model was trained? MLM task, masked language model, right? So yeah, so we actually trained MLM, right? I showed in this picture also. This one. This is what a masked MLM looks like. Okay. Any questions before I end my presentations? I have two more slides, but I would spend time on them if there are no questions. Otherwise, I open the floor to the audience so they can ask questions. Yeah. And please open the chat window if people have questions.
They can ask questions.
Okay. I will wait for a minute. If there are no questions, then I will go to the next slide. Ma'am, I think you need 15-20 minutes for your
even lesser than that, Harshit. Just that it was earlier I used to go 20 seconds per question, and then there was a feedback that they said quiz time is very less. So this time I made 30 seconds.
Good.
So just 5 questions and 150 seconds is what. So it's launching and then, making them answer probably 5 to 7 minutes, not more than that. So if you want an additional, few more minutes, I think you can take.
Yes, I do have 2 slides.
Sure. So any questions, participants? You did hear the speaker mention that the best way to say thanks to him is to ask questions.
Yeah. See, there are certain things when we as a teacher are teaching you, we make assumptions, right? And it is very difficult, at least, if I have a regular class, I know what my students already know. There I can, articulate, position myself. But in, these kind of sessions where I do not know the background of the students, it is on you to ask, and don't feel shy about it. There is no shame. And I know one thing from my experience, a question that you are going to ask, most likely many more students want to ask the same question, and everybody is looking at the other person to ask the question. I can tell you from my several years of experience as a professor, and being as a student also and as a professor also. I used to teach earlier. Students all have the same question, so please do a favor to yourself also and to your fellows. Ask a question. They all have the same question.
So Priyadarshini has a question on foundational model. Her question
Yes.
is it expensive to run the foundational model?
Very, very expensive, actually. Not only run is one thing. One is training. Training a foundation model needs GPUs. Initially, we only had one GPU. So Pranjal, you heard him last time, right? Pranjal used to um, train this foundation model, actually. Pranjal and Karan, two people. They would submit a job every day to the GPU. We used to get a 24-hour queue, which means that after 24 hours, the job will automatically finish. And I skipped one slide. As I said, you asked me questions, I will give you a lot of information, right? You don't ask me, I will also skip. So here, this is, we were training for 30 days. Every day, Pranjal would, in the evening, 5 p.m., he would go and submit the job. And then next day, record the number, right? Um, and this is, we keep doing that for 30 days. Why 30 days? Why not 25 days? Why not 20 days? As long as the loss is reducing, we kept the training on, right? That is how people do training. It is an expensive. Not you need patience, you need time. But then if you have lots of GPUs, say 100 GPUs, thing that you do in 30 days, you can do in few hours, right? But thankfully, today, now we do have lots of GPUs. What we used to do in 30 days earlier, now we can do it in a single day. So number one thing is training is expensive when you are training a foundation model. The number two, now you have trained a foundation model, you are applying this, right? When you're applying this, then also you need a GPU, right? Um, uh, so you don't need 100 GPUs at the time of application. Just one or two GPUs are enough. Depending upon, in our case, we just need one GPU, right? So yes, GPU is still expensive, right? There's a cost to it, right? Yeah, I think I have answered.
Priyadarshini, if there is another question follow on, let us know. Kesava Harsha from Hindu College of Engineering, Guntur. It's based out of Guntur. Her question is: are there any applications that use AIOps?
Yes, there are lots and lots. It's a big industry. AIOps is a big industry, right? There are plenty of applications. In fact, all applications need AIOps. Think about it. Like when I motivated the problem in the beginning, there's a bank. Bank has a website. If you are withdrawing money and in between the website goes down, won't you curse the bank that you need money and it is not responding, right? You are chatting to somebody on your WhatsApp and the WhatsApp system goes down. Won't you be very impatient? I'm not able to send message, right? When all these things, applications go down, who solves the problem? AIOps. If AIOps is not there, then we need a human to solve the problem. If human has to solve the problem, it will take more time, right? We're just automating what humans used to do. In fact, we are not replacing here. We are helping the humans to resolve the problem quickly using AIOps. I hope I answered your question. There are many applications: banking, train ticket, air flight, you name it. Yeah. There is one more question. Shall I, Sujata?
Yeah, go ahead. I'm not able to see that. So if there is a question to you, you can ask.
Nama Sivayam, I'm sorry if I'm not spelling your name correctly, but Nama Sivayam, right? Has a question which says that, is there enough amount of log data sets to make these new LLMs industry ready? Very good question. Very good question. One of the challenges, like I said, let me give you some context, and thank you for asking that question. Let me go back here. Yes. See, these models that you're seeing here, they need massive amounts of data. And I know why this question has come, right? Do we have enough data to train our own foundation model, right? remember that this encoder only model, this was trained on wiki books, right? It's a huge collection of books that are available, right? Um, we wanted to train a foundation model on log data. So we actually have our own log. See, IBM has lots of products, and for example, WebSphere, right? And there are many more uh, products that use open source, products also, such as Kafka, right? We have our own databases. So we do have internal log data sets. We also have log data sets available from outside. Those are available in the public domain, right? We actually used approximately 100 GB of data for training, which is not much actually. 100 GB is not huge, but it is still a substantial amount of data. And that is why training was taking time. When I was saying, right, we used to submit every day in a queue would end after 24 hours. Longer queues were not available at that time when we were doing this work, right? So to short answer is yes, we do have enough amount of data. We took almost 100 GB of data to train the model. Yeah.
Okay. So there is another question. What if the rules mentioned in runbook are not met?
Yes, as I said, let's go back. Actually, most of the time they are not met. So I want to give the right picture here. You're lucky if they are met. Oh, so well, I take my statement back. Sometimes they are met, sometimes they are not, right? Um, yeah. If they are not met, then that is why you need a human to intervene, right? At least human knows what the problem is. See, to solve any problem, now you can take it, draw an analogy, right? If there's a problem going on, right? First of all, the most important thing is to identify where the problem is. Because if you don't know what the problem is, you will not be able to solve it. Most of the time, the most difficult part is to find out where the problem is. And AIOps actually helps. The story that you see here, it helps in identifying where the problem is. Once that is identified, I think 80% of the job is done. Support engineers tells us that they spend most of the time in identifying the problem. Solving is easier. Finding out where the problem is difficult, right? Because log data is huge. It's not easy to find the problem. So AIOps is mostly helping in identifying the problem, where the problem is, and if a known solution is there in the run book, go ahead and execute it. And to your question, if it is not available, at least support engineer knows what the problem is. He refers the run book, the support engineer refers the run book, and sometimes do some stitching of different things and then execute it. The problem is solved. Yeah. So some human intervention is still required to solve the problem. Yeah. If the ready-made solution is not available in run book.
I don't know if Priyadarshini's question I understood. I will paste it for you, sir. Just see what she has written. I'm not able to understand this. Just give me a second.
Okay. Is it FI for your information? I think you said an anomaly detection, etc., but still the first fishermen of it like they don't know whether they have crossed the water or the. I'm not able to follow what the question is. I'm sorry.
Yeah, so Priyadarshini, we didn't understand. So even I was not, the question looked vague. I tried to ask her to unmute, but she says she has audio problem.
I see. Maybe she can write it again.
Yeah, please look into the question, Priyadarshini, and get back. On the run book, the question was from Sandeep Krishnan from Kalangya Karunanidhi College of Powai. If there is any follow on, Sandeep, please let me know. I think you can finish your session and we can take questions a little later.
So there is one more question I can see from Vishnu. May I answer that first?
Yeah, please.
So what are the complexities with ITOps data, right? So ITOps data is what? Log data and metric data, right? Metric data is numerical, like, memory consumption, CPU utilization, cache memory consumption, and so on and so on, latency, right? Um, Log data is actually very different from the text data. These are the challenges with IT ops data, the log data, as you see. Log data is semi-structured. It's not in human language, right? Look at this log line. Servlet error dash com dot ibm dot ws blah 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 blah. javax dot net dot ssl dot ssl exception received fatal alert protocol version. Look at the above one. I don't even, this is not grammatically correct. This is like JSON object, right? It could be short sometimes. So these are the challenges and complexities of IT ops data. It is noisy, not grammatically correct, right? It's not human readable, right? Like this one, this is like one token from here to here. Error dash com IBM WS web container extension default extension process. Yeah, that is one complexity. Any more question, Vishnu? I think I have answered your question, right? This is a few examples of showing what are the complexities of IT ops data.
Remember us asking one question: are there any ways to reduce the time consumption in training foundation models?
Well, get more GPUs. That is one way, right? The more GPUs are, the faster you will train. But Chat GPT, as you know, months and months of effort has gone into train those kind of models. They are huge. Yeah, there is there are actually, it's in a research thread. It's a research topic in itself. There are ways, but maybe I am not aware of what are the ways. So I would say go and do some readings on that, different ways, but there should be some ways of reducing the time to train. Yeah. Any other questions?
No, nothing more that I can see.
So maybe I can just take next 5 minutes talking about what we do at IBM Research, right? Just for the general audience, so that they know. They must have heard about IBM. I just want to spend 2-3 minutes on IBM Research. What we do at IBM Research, right? So these are some of the topics that we are highly invested in. Supply chain, right? Building models for supply chain, AI models. Conversation, we are hugely invested in conversation AI. IBM has a product, um, uh, Watson Conversation, Watson Assistant, we call it. AI automation, automating the AI platform, right? Hugely invested in these two. Hybrid cloud is another very focused area for IBM. Quantum computing and security. So the work that I'm talking about, this AIOps, this comes under hybrid cloud and AI automation. So these two, it's a joint work between the. I earlier used to be part of the conversation team, conversation AI, until 2019. I was doing conversation AI, but then I used my expertise in the hybrid cloud for the building this AIOps platform, right? So I needed to know about AI. I also need to know about the AIOps. This, how do you troubleshoot issues and all that stuff, right? So, and that comes under systems, hybrid cloud. And there is trusted data in AI. Trusted data in AI means that the data that we are using, is it clean data? Is there any issues with the data, right? Is there any biases with the data? Data quality issues, right? That comes under trust. And we are using AI for that also. Language is basically language modeling in general. Code, using AI, you can now generate code that comes under language and reasoning, right? So we are building AI models for reasoning, for language translation, and so on, right? And climate. Climate is where, so IBM Research is also invested into, building models for industries like mining, right? For climate, models for AI models for climate, right? So these are some of the areas where we are heavily heavily, we have people working in these areas at IBM Research. Yeah. Thank you. I think that is all I have for today. Yeah. I hope you learned something, and that is the ultimate goal. That you learn something out of these three presentations that we prepared for you. You gain some knowledge and be able to use that knowledge. Apply it, do some projects. And yeah, thank you very much for providing us the platform to communicate with such a large audience. So
Thank you. Thank you, Mr. Harshit. Thank you so much for this wonderful session. And I think it was pretty interactive. Students, once again, reminding you there are multiple ways you can ask questions. Sometimes it's better to avoid this, one-sided communication. Raise your hand. You can ask questions. We would like to hear some other different voice too. Before I move on to the Slido quiz. Yeah, the Slido link I have been posting. This is where the quiz will be. Before that, I would like to invite now another student representative from GRT Engineering College of Technology based out of Tirthani, Sunita. Sunita is a student leader of GRT. I would request her to turn on your video. She has volunteered Mr. Harshit to summarize today's session. She said she is noting down, very keenly making notes and trying to summarize it for the benefit of the students and other participants. So
and
Sunita, over to you.
thanks to her, yes,
Yeah.
for the summary. Yes.
Good afternoon, sir. Good afternoon, ma'am.
Good afternoon.
First of all, thank you for the opportunity. Myself, Sunita, student leader from GRT Institute of Engineering and Technology from Computer Science Engineering. Following the first session by Mr. Aravind, second session by Ms. Pooja Agarwal, Mr. Pranjal Gupta. Today, our third session was led by Mr. Harshit on Industry Assisted Lecture Series on AI for IoT. Today, the session was started by Mr. Started our session by unveiling the mysteries of the digital shift that has taken over our modern world in a time where complex seems to be growing at an unpredictable rate. He shed light on the crucial importance of the customer experiences. He spoke of the art of business observation, where we analyze and interact with the applications to aggregate structured and unstructured data, where we get the results. In this vast sea of information, that we find the metrics and anomalies that we so vital the health of our systems. But how do we make sense of it all? Mr. Kumar explained the intricacies of pipeline structures and downstream tasks, and they delved into the wide realm of neural network. These networks, with their hidden layers capturing the weight of information, playing a vital role in the classification of system. And yet, the path is not without challenges, as he pointed out. One of the most significant challenges lies in log data, as one student also questioned in the Q&A session. Here, we navigate the water of golden signal classification, a key observation in ensuring our systems remain robust and resilient. Finally, ASA stressed the importance of training on large data sets, for it's through this process and then we unlock the true potential of our systems. At the end of the thing, he explained about what they went through in their IBM and what all this. And this is all. We will take what we have learned today and apply it in our work, our project, and in our paper. And once again, thank you for the opportunity. Thank you, sir. Thank you, ma'am.
Awesome. That is a very good summary. Thank you.
Thank you, Sunita. Wonderful job.
Thank you, ma'am.
Yeah. So now I hope all of you are ready for the quiz. I'm going to share the screen. And I would request all of you to move on to the browser. This is not new to all of you, but those of you who have just joined for today's session, you may find it new. I would I'll give another 30 seconds more because we want to finish this on time. 360 participants. There are 540 in Zoom, so I think 200 are again missing. If we reach 400, I will start the quiz. We want as many participants to join the quiz and take these questions. The questions are based from the session today. And Sunita did a wonderful job of summarizing it for us. So I'm sure the quiz questions will also be easy for you to answer. 7 more to go, 393.
These questions are very easy. Trust me.
Okay, now let me start. Here comes the first question. So as you can see, it is a timed question. 20 seconds has been given. Okay, and the right answer is option B. Now, good, this was not the question from the speaker. This was a question that I had added for you to get used to this platform. Those of you who have been attending this with me for the last 2 sessions will know that I'm just giving you a practice question so that, you don't complain to me later that, ma'am, we didn't even understand what this platform is all about. And by the time we figure it out, we are done with all the 5 questions. So I'm giving you one more practice questions for 20 seconds. Okay. Actually, the right answer is option D. So this is the right answer. Now, what did we learn from these 2 practice questions? It's a timed question, MCQ. You need to choose the right option within the 20 seconds. Now, until last week, we had set each questions for 20 seconds. I did see multiple people give me a feedback that quiz time has to be increased. Yes, we heard you, and we have now made it to 30 seconds. So from now on will be the questions from the speaker. The third question, which is the first question from the session today. So here comes the next question for you. 30 seconds for you to answer the question. Okay, all of you have said option B. Let's see what is the right answer. And it is option B. Good. Moving on to the next question. Wonderful. I did reveal it even before I clicked. Yeah, answer is option C. Moving on to the next one. Okay, and the right answer is option A, which is 48% of you have answered it right. Next one. Okay, and the right answer is option A. 34% of you have got it right. Probably I'll let the speaker dwell on this particular question a little later after we finish. The last question for the day. Okay, so this is another question where most of you have got it wrong. It is option A. I don't know if I was making mistake. Vishnu has a thing, ma'am, for the last question. A and C are correct answer. Okay, for the
That
previous.
is right. For the previous question, both the options are correct, A and C.
Okay,
Question number.
so I think we didn't see. Okay, that's fine. So if you can come back to the Zoom screen, all the participants, we are done with the quiz. Come back to the Zoom screen. We have, this is the leaderboard position. Muthulakshmi, Priyadarshan, Kaladevi, Subhashini, and Jiva. All of you have got, first three of you have got 7 on 7. And Muthulakshmi is at the top because she did the, fastest finger. 1 minute and 24 seconds. So thank you so much for participating in the quiz. Yeah. So I would now request Dr. Kelita Cherian to, finally give us a conclusion on the series and also the session.
Yes, Dr. Harshit, I think today you definitely got to wear your professor hat once again and take the students right from the basics, very patiently, I should say, walking them through the intricacies of your lecture. So just before I conclude, I just want to know, would you like to give the explanation for the question? There was one question where most of them got it wrong, right? Would you like to just explain that?
Yes, yes. So that is so that question was about multi-class classification and multi-level classification, right? And I did have an example in that picture, right? Where
Yes.
if you have got to choose only one option out of the multiple classes, and then it is multi-class. But if you got to choose more than one option, then it is multi-label, right? In this case, it is only one option, right? So that is multi-class classification. It is confusing. I know that many people get confused, and that is why I specifically have that in the slide and also a question for that, right? There's a very fine line of difference between multi-class and multi-level, but that's why I strongly encourage you. It's one of the interview questions we ask also. Yeah.
Okay, so you got an insider's tip now as to what could be possible interview questions for you later on. But do read up on more of this as Sir has laid down the basics for you to understand. And for more deeper knowledge, I would request that you go back and read up more on these topics. So I think the AI for IoT series of lectures by the IBM Research Labs has certainly been an enlightening series because it has given good visibility for students and faculty who have attended this into Industry 4.0, IoT and deep learning models, followed by the complete exposure to AIOps and the application of AI for IT operations, along with the tools and the foundational models that IBM Research Labs have developed. And I think what has come very clearly through this is the importance of AI ops in bridging the gap between the business and the IT teams, and also in helping give a good practical exposure to the business implications that can get affected, if such a function does not exist within the industry. And I was one of the reasons for our industry assisted lectures is to give students exposure to the practical application of emerging technologies within the industry. And through the 3 series of talks and the various models and tools that you have shown us, including the live demo that was shown last week, I think participants have certainly got an idea or an insider peek into what happens in the industry. So we're very thankful to all the 4 speakers from IBM Research Lab for coming to our platform, sharing of their knowledge, expertise, and their time. And I believe that students have benefited, and you will use this, as Dr. Harshit said, that there has been learning and that you would use this knowledge in your own colleges, in the projects that you have to work, or in any other problem statements or other areas that you will work on during your academic course. And I'm also thankful to both the student leaders who volunteered today. Both of them are from new colleges, Brilliant as well as GRT, our new partner institutes of PALS today. And it was good to see you having come forward and confidently putting your points across. It's also worthy to know that it was 2 girl students who came up amongst this huge platform of students. We've had 1,000 participants in the first series, 700 in the second, and I think today we had 600 plus. And out of this whole group, it is 2 girl students who came forward. So it is very heartening to note that. And I hope that in future lectures, we will see more of you participate in such initiatives. So once again, we thank you all, both our students and faculty of our partner institute, for attending this, as well as our industry partner, IBM Research Labs, for facilitating this. And thank you, Sujata, for being our moderator for the entire series and holding the fort on behalf of PALS.
Thank you, Kelita. So thank you, Mr. Harshit, for all the patient conversations we had earlier and for your patient delivery today as well. So wonderful, sir.
Thank you.
Thank you. So participants, I do see that we are dropping out fast. Before you leave, make sure, the PALS protocol is followed. Give your feedback. Feedback logging is very important. We look at continuous improvements every time. And we are also planning to conduct an online quiz similar to the ones. I do not know if there are participants who attended the EV series, the last series that we had conducted. We did conduct an online quiz from all the 5 sessions earlier. So this series has 3 sessions. So we will have questions from all the 3 sessions, and we will have a small window in which that quiz link will be open. You'll have to attempt the quiz within that link, and then that is when the certificates can be awarded. So taking quiz is mandatory. Watch out for mail from us. We will inform you on when the quiz will be conducted. So with this, we come to the end of the series. Thank you so much for watching. If any of your friends or if there are faculty who think, the other students will have to watch this session, I will be sharing the recording. Kindly circulate it among your friends and other students. Thank you so much. Thank you and have a good day.